Welcome back. We're here now to talk about 5G and how it will drive innovation. And I have with me Paul Scanlan, and Paul is CTO of the Carrier Business Group at Huawei. So he's an eminent expert of all things network and in particular 5G. And that leads me to my first question. I mean, you've been around the blocks, the telecoms block. You've seen 2G, 3G, 4G, and now 5G. Tell me, how is 5G different when it comes to innovation or the innovation it enables?
It's actually a better way of phrasing the question, Ludwig. But thank you very much. It really is all about innovation. You know, when we're developing the standards for 5G, one of the two important things that aren't really always discussed is about efficiency, green. Yes, so if you continue building 2, 3, or 4G networks, you're going to double the carbon footprint of the planet just by building those types of networks. But the efficiencies that 5G brings in lends itself to actually reducing the carbon footprint of mobile networks, and that's something we never talk about, right? So that's perhaps on the fringe of this concept of what does 5G do innovatively. But the second one is probably around some of the technology features that it has. And I think perhaps I'll explain it in two different ways. The first way is think of 5G rather than being faster, think of it as being a bucket that holds more than a 4G bucket. So it looks the same, feels the same, yes, but you can get more out of it. So if you can get more out of it for a similar sort of price, then obviously your cost is going to improve, your cost structure is going to improve, and that's particularly important in terms of driving down the operator's cost point, and that of course translates to better pricing models for subscribers in the B2C business. But if you think about this big reservoir, you can actually do a lot more with it. So I can service more customers. So we never really talk about 5G, say, in rural areas. But if you imagine something that's very, very efficient and being able to drive and provide an equivalent amount of capacity to more people, then obviously it means you can start bridging the digital divide. There are probably two answers you never really expect when you hear people talk about 5G. The more classic answers are really skewed towards the things like, I think, network slicing. And I would say network slicing and the uplink capability of 5G. And that's been demonstrated just over the last 2 years of the pandemic, where 2 years ago you couldn't sell an e-education or an e-health service or video conferencing, teleconferencing, for example, to any CMO to write a business case. I don't think anywhere around the world, right? I certainly remember talking to them about it. You couldn't do it. But because we can't travel, our behavior's changed. And now we have all the dynamics and the data to understand people's behavioral changes and what they will accept. We also have hard evidence, the data, if you like, of the data traffic, exactly how much. And just as I'm broadcasting to you and you're broadcasting to me, it's not a Netflix story. It's not a download, which is what drove 3 and 4G. This is all about uplink. It's all about user-generated content, whether it's in healthcare or education or any of the others. Cameras everywhere. So 5G, runs at about 2 gigs per base station, whereas 4G is somewhere around 75 megabits to 150 megabits. So you can see it's an order of magnitude or more better. So for the type of services that we're using now, video, content, user-generated, it does that better. And perhaps the best way to describe, say, the network slicing component would be an example in a mission-critical area, say running robots in a factory or even doing some remote diagnosis or even video-based conferencing in a hospital or using other telemedicine solutions. You wouldn't want to have a shared network like 4G is and have children playing games and consuming bandwidth while somebody else is trying to do an operation or take MRI images and things like that. And 5G guarantees that SLA through the concept of network slicing.
So it's faster. It gives you more bandwidth. You can do more. Well, what does that mean then in practice? Can you give me a few examples of what that network, what 5G enables?
Yeah, I mean, I'll give you some very I'll say unusual examples. Let's take a racetrack, Formula One racetrack, for example. At the moment, everybody pays their $1,000 and sits on the start-finish line and watches the cars take off and zip, and a couple of minutes later, back it comes around. But you have now the opportunity through either large screens, 8K screens, or devices in your hand, and because of the latency and the ability to do what we call the multi-edge computing, so we can do the computation there on the spot, then you can have a very, very close to near real-time experience on a handphone or on the screen to see what's going on beyond your vision, right? But you could do more. Let's suppose I put on a pair of glasses and the glasses were AR and perhaps a VR glass, but let's consider this mixed reality glasses. I could put them on, and if I wanted to, I could be at the same time as the race is running, I could be racing against Hamilton and the others in real time. Or perhaps I'd like to learn how to drive a race car, and I can be almost in his seat and experience how he's doing things just at the same moments that he's doing that. We've even explored these concepts in other sporting events like stadiums, where we've had 30 or 40 cameras in the stadium, three-dimensional cameras, and playing game of sport like soccer, for example, and you want to see how, perhaps before our times, but Pele and others are playing, and you want to learn how they do it, how they position themselves as they're doing these things. You can do those sorts of things. So it starts to give, in the sports and entertainment sector, quite a new series of opportunities in that market. So that would be an example there. The education, not education, but the healthcare one I just gave you was sort of some remote monitoring. But a classic example we demonstrated here in Shenzhen was over a couple of 100 kilometers. We had remote ultrasound. So we had the technician in one laboratory, and he had one end of the ultrasound, which was the screen, and then at the remote area where the patient was, we had a triage nurse. So the triage nurse is using this device which looks a little bit like a pen on a floating gimbal, and she's prodding and pressing and the patient around the abdomen. And a couple of hundreds of kilometers away, here's the technician, the doctor, having a look and seeing what's going on, but he's actually can do things remotely. So she can put it on, and as he presses 200 kilometers away, it's moving in synchronous, yes, very close to. So you imagine this time sensitive, this feedback that's required. If you don't have the latency that something like 5G can deliver, then it'd be very easy to press a little bit too hard and suddenly have a problem at the other end. So remote monitoring, remote diagnosis is enabled through 5G. Some of those, you could argue, could be done with 4G, but as I mentioned, the ability to slice it, this very low latency, those things are very critical in certain types of applications. We did other examples in mining. We've also provided very, very example of capacity in mines, so providing very high and low latency feedback to the remote control areas, so they don't need to put people in the mines as they're mining. So that's a safety improvement as well as a productivity improvement. And this sort of concept of having significant amounts of data, if you want to take data from, say, an MRI laboratory or a CT scan laboratory, and you want it in real time to analyze it with surgeons or specialists in another city, another location, you've got these huge volumes of data. It's just not practical to send that sort of stuff over a 4G network. But again, some of those will have fiber components.
Yeah. So it seems to me, so what 5G provides is kind of real-time connectivity almost everywhere, ideally, at least. But I mean,
well, as long as you provide the coverage, yes.
Yeah, as long as you have the spectrum and all that. But I mean, give me some use cases of where Huawei has introduced 5G kind of and helped companies not only to be more innovative, but perhaps more efficient.
If I'd like to stick on the healthcare sector for a moment, because I think that that's very topical, as you can imagine. So let's take, I think the world heard about last April here in China. The government or the health authority built two hospitals in 10 days. Yeah, so very, very rapidly. And Huawei built 2 5G networks in 3 days. So 72 hours, we built the entire 5G network. And within a couple of weeks thereafter, we had a cloud AI solution built into that scenario. Okay, so we sort of piloted it there. And what we were doing was we were experimenting with imaging very specifically, because at the time you couldn't really diagnose COVID with certainty other than through chest x-rays. And the bottleneck, and this is the key, is with a specialist who can look at the x-rays and with certainty say yes or no. Okay, so you imagine thousands of people can get x-rayed, but it takes a specialist a finite amount of time to actually determine yes or no the person is infected. So the challenge you have in the healthcare sector is providing this type of efficiency. The limited number of experts being able to provide healthcare to the masses at an affordable cost. So what we did was we started crunching all these images and putting it up into the cloud, and then started training the AI. So one thing, as you mentioned, so we have a lot of data. So that's the fast bits that we have. We've got to move this data very quickly. But the other one is you need the capability of 5G to connect a lot of different things often to be able to put it in the AI. So the AI can start looking at different type of scenarios that maybe an individual wouldn't necessarily think was correlated. Yes. And I think that's really where the opportunity lies. Now, Ludwig, a year and a half later, Ken Hu, our rotating chairman, said just 2 weeks ago that we had finished 1,800 hospitals. So 1,800 hospitals in China now have that capability. Yep. Now, to be able to do that, you need a lot of the back-end infrastructure. So you need all the transport network, which is all the fiber-based network. You need to have the cloud infrastructure in there. You need to have the AI algorithms and everything. You need the business process in the hospitals. You can't just put technology in and hope that the doctors will use it. You need an ecosystem of different players who write the software and doctors trained in and with confidence to be able to use a lot of these scenarios. So I think that's a very, very topical example. And yes, we may have started out using chest x-rays, but where do we go beyond that? There you are in London, you might have a laboratory behind you, and you suddenly decode something. All that vast amount of data can be pulled up, and I can see it in almost real time over here, and we can collaborate together. And I think that's the other thing that people are missing in their geopolitical issues around the world about this thing called 5G. Because if we were able to build the networks more quickly, as you mentioned, it's an enabling technology. If you can connect everything and collect the data, then you can analyze it. And that's when you really get the business benefits. So in mines, we've seen efficiency improvements, which we've been doing in China, in the ports, and safety, saving lives, because you don't need to put people down in the mines to be in a dangerous environment. The other areas we've been exploring have been in the ports. We've done a significant number of ports. So we provided cameras and sensors throughout a port, and that's about efficiency as well. So you don't need to provide crane drivers at each of the cranes to lift all the cargo on and off. It can all be done centralized. It could be done anywhere. It could be done in another city, for example. So manufacturing, healthcare, mining, ports, these have been the low-hanging fruits. We have been experimenting with education, but again, education content, it really depends on how education is done. And just as we're collaborating here, or I'm giving you information, you're giving me information, in a way it's a type of a tutorial. The same sort of challenges we have, which is user-generated content. The challenge we have is a lot of this is based on Wi-Fi. Probably you're in Wi-Fi, I'm on Wi-Fi, so there'll be some limitations. But imagine if you could do these sorts of things with 4K, for example, then suddenly the ability to see exactly what I'm handwriting or how I'm doing, or the skin color of the texture, or painting remotely, all of those sorts of things go beyond doing straight, I'll teach you mathematics or English.
Yeah. No, there's, of course, 5G, that's public wireless networks. But there's also a lot of talk about private networks, and I wonder how important you think those will be. And by private networks, I mean companies building 5G networks.
Yeah. So this is a tricky one to answer, and I'll go through some of the scenarios, and then you'll understand why I can't just say you should do it this way or that way. But my gut feel is it ought to be a sort of a public managed private network, and I'll explain why I think that way. Unless you're a very big enterprise with a lot of very good technical capability, and that is your area of expertise. If you're a hospital, right? A hospital does not have the financial resources to be able to afford the first thing that a telecom operator does, which is 5.9 reliability. Okay, 5 nines. The best they can do is maybe 99.93 or 9.45 if they've got the money. So the first thing you get from an operator running a public network is 5.9 reliability. The second one you get is security, all right, in terms of being able to provide the firewall capabilities and a range of other things within a private network, a public network, right? So If you have a lot of cash and you have a lot of technical expertise, you could argue that I could build a private 5G network. But then you look at the next component and say, well, is your job to be a telecom company or to provide healthcare or to provide education, if you follow my meaning, yes? So the bread and butter of a telecom company is to do that, an operator. That's what they do. That's what they do best. So if we now start to look at things like spectrum, if you start fragmenting spectrum, so give a block here to an industry sector or to a private company, then, and you limit the amount of spectrum that you're giving to a telecom operator, then you start to reduce the efficiencies that I mentioned 5G introduces. So that's these are all the components you need to consider. Yeah. Yes, in terms of providing network slices, the operator can do that with confidence. And there's no reason with virtualization and others why a private company could not do that as well. So these are the sort of the components that you have. How would you do it? Why would you do it? Are you good enough to manage it as a core business, etc., for your business? But the challenge the telecom operator has and the industry have is telecom operators for the last 30, 40 years build a tower. They pay billions for license, pay also hundreds of millions for network, build a tower and sell SIM cards. But now they've got to go and talk to a manufacturer, every one of them, and they all have different requirements and different challenges. So how do I engage and how do I scale up that in the same way that I build a tower and sell millions of SIMs, or go and talk to a hospital, or go and talk to the bank, or go beyond selling simple private leased lines as an example. So we have some mindset changes. We have some practical choices, and we have some very specific capability decisions to be made between the industry sectors, not the industries themselves, but the sectors within the industry, and that includes the telecom operator. So it's not one size fits all. You do see some companies in Germany trying to build who have successfully built their private networks. They're very good at it, just as the Deutsche Telekoms, the O2s, and the Vodafones are very good at it.
Well, another question about kind of innovation in networks, and there's also lots of talk about O-RAN, kind of building networks, or 5G networks with a more open technology based on common standards, or even more on common standards. And you have been a skeptic. Explain why.
All right. My skepticism is largely based on sort of 40 years of experience in how because I worked in telecom operators before I joined Huawei. And even now with my engagement when trying to sell products and services to telecom operators, yes. And the first one comes down to, you might have you've got a great product, but what is the product roadmap? Okay, so just keep that in your mind. What's the product roadmap? Okay. Now let's come back. That assumes you've got a product today, right? An O-RAN product today. So you're a new kid off the block and you've got this new thing called O-RAN, or you're even a Huawei with a new O-RAN product. What's the product roadmap going to look like before I start an investment in an alternative technology? Let's backtrack a bit now and say, well, how did we develop 2G, 3G, and 4G? We developed them through standards, yes, through the 3GPP and a large group with ETSI and ITU and GSMA associations. We sort of built up this inertia based on standards. And the reason we want standard is for interoperability. And the reason we want that type of interoperability is so that we can have ecosystems. And a great example would be 5G. Today, you have about 450 million devices within 2 years. You have about almost 1,000 devices in the ecosystem, and you have prices that are approaching $100. You didn't see that for 4 or 5 years in 4G. So the adoption through the ecosystem was terribly important because of standardization, yes? You could also argue that perhaps COVID has plus or minus in different countries accelerated some of that deployment for different reasons, yes? So the first one is then standardization. You've got product roadmap at the very end, but you've got standardization here. And then you've got interoperability. So even you have a brand new product from the same vendor, or you have a new product from a new vendor. The latter is worse, because if it's a new product from a new vendor, you're going to have to go through significant amount of interoperability testing, because you don't have a network today that's homogeneous. It's not all one 4G network, all supplied from Huawei, for example, or Ericsson, or anybody. Okay, every telecom operator has a diverse portfolio of vendor strategy, right? To balance the market share for competition, and also they don't put all their eggs in one basket. So now you're going to have multiple generations of technologies from different vendors, which is your current in situ network. And you're going to come along and say, all right, now you're going to have to test it in this configuration and that configuration and that configuration. Yep, that takes time. So it takes a significant amount of time to be able to standardize things. It takes a very long time to do interoperability testing. And then once you get over those hurdles, then it comes down to commercial and after-sales servicing. Yep. So these are practical things. And you're not going to get more than about maybe 5, maybe 10% of the network. And you're not going to get it in New York City or Washington, D.C. or San Francisco, right? They're going to give you somewhere out there. So that's a program that's going to take quite a few years. Yeah? And even if you're very good at writing software and you can get some reasonable hardware off the shelf and package it all up together and you're very, very good at it, it's going to take you 18 months to 2 years just to get to the step of interoperability testing before you get to the network deployment. So, and that's without standards. If we said, let's take a standard and say we want to make an ORAN standard, the last one I'll throw in is really who's in charge? Ludwig, who's in charge? You're going to make the hardware. Somebody else is going to make the software. Somebody else is going to make the application. Somebody's going to make the middleware. And I'm the operator and I want to sign. Am I signing with you or him or him? And what's the deal? What's the back-to-back agreements that you've all got so that if you upgrade the hardware or the software platform or you need more lines of code, the hardware is going to support it or the memory or this? Yep. And the last one, which is the first one I started with, is the operator's key consideration is OPEX. And a large portion of that is based on site. Well, in fact, it's almost all site related. So it's site rental. That means he who can miniaturize the thing, make it the lightest, smallest. And then what about power? 13% of every operator's site is power. That goes on forever, every year.
Sorry to interrupt, but we've run out of time. That was very interesting. It's kind of ORAN, how this plays out will be very, very interesting. But thank you, Paul. This was very helpful. Thanks for your views, and hope to talk to you soon again. Thank you.
Thank you, Ludwig. Thank you very much.